Yes, guys. So today I'm taking inverse trigonometric functions, or they are known as inverse circular functions. Okay, or this is known as inverse trigonometric functions. They are taken, or circular functions. Inverse circular functions. Why circular functions? Because trigonometric functions are also known as circular functions because they are defined in form of a circle. Circle is in terms of radians. Okay, pi by 2 something or pi or something. So in that way, it is known as circular functions or inverse trigonometric functions. Today's topic is. Okay, so these questions are taken from students' queries, and I'll just clarify one by one. What are the inverse functions? How they are defined? What are their properties? Okay, we have talked about some properties also. Okay, what are their principal values? What are their general and principal values being defined? How they are defined geographically? Okay, graphically, not geographically, but graphically. How with the help of a graph we can define inverse trigonometric functions. So that I'll just draw the graphs here. Sorry. So these graphs are okay just to help to understand that how inverse trigonometric functions are defined and what is trigonometric functions and inverse trigonometric functions, how they are okay graphically defined. Okay, so the difference between them I'll talk about, and after that I'll talk about how to find the value of one inverse function in terms of another inverse function. So one inverse function is defined in terms of another inverse function. There are 6 inverse functions, trigonometric inverse functions: sin inverse x, cos inverse x, tan inverse x, cosec inverse x, secant inverse x, and cotangent inverse x, or cot inverse x. In this way, 6 trigonometric inverse functions are there. And they can be expressed in terms of one each other, okay, or one another. In that way, we have to define them. These 5 questions are taken theoretical, just to understand the basic topic of this. What is the inverse function that we define? What is an inverse function? Okay, circular or trigonometric. So that we define first. Okay, after that, one by one, that we verify every bit and corner of this. Okay, but define every part of this trigonometric functions or inverse trigonometric functions. Let me define what is inverse function. An inverse function or inverse circular or trigonometric functions. Inverse trigonometric functions or inverse circular functions that we have to define today. And I'm discussing today what are these functions. Inverse trigonometric functions. Any function defined that we have defined already. Let's suppose a function is defined like this. F is defined from, let me take x to y. This is a function from x to y. Or if I say that x equal to fy, okay, and x to y, x is a function of y here. In this way, we have defined x equal to fy, and suppose g is another function which is from y to x. Y to x. In this case, y is a function of x. So g or y equal to small y equal to g into x, or function of x here. Y is a function of let me take this f itself. So here y is fx also. In that way, if y is fx, or let me take g by here. G, I am denoting the function here. So y equal to gx here. So y is a function of x. X is a function of y. Okay, in this case, or where x belongs to capital X, small y belongs to capital Y. X belongs to capital X, and y belongs to capital Y. So this function of let me take, if f is a function from x to y, let me take x to y, okay, or y is a function of fx, let me take, then g by, or g is inverse function of this. So g is equal to, let me take f into y here, or f into y, let me take. G is just the reverse of this. G is a function of x, f is a function of y, we should take, or y equal to f, in this case we are taking. So if I take G inverse of this, G inverse equal to F inverse of whole inverse, because here if I take G equal to, this is Fy here, or F is, in this case Y is a function of X, so this is F of Fx, or F, let me take F of G, or in this case of Fx. F is a function of Fx further, or let me take G inverse therefore equal to F inverse of whole inverse, but F is a, they are inversely proportional feature. Okay, so F is a F inverse of this equal to G. Let me take G here, F inverse equal to G, or G inverse equal to F. So they are inversely proportional feature, and F inverse, G is inverse function of F, and G inverse equal to F here. If I put here F inverse equal to G, so G inverse equal to G, the basic thing is this. In this case, F inverse equal to, or this is F inverse here, F inverse of whole inverse, let me put here, this is F inverse equal to G, this is nothing but G inverse here, G inverse equal to G. In this way, this is proved. Okay, so in this way, we can prove that F inverse, or this vice versa, means when, now in this case, the function F or G, they are one onto function, uniquely defined, and then they are inverse of each other. Inverse functions are in this way defined. Okay, let me take here sin theta, let me take sin x equal to theta, let me take sin theta in terms of trigonometric function. Let me define that sin x equal to theta, then x equal to, you can express this in sin inverse theta, sin x, so x is taken to sin inverse. So here x is a okay, x equal to sin inverse theta. Sin inverse theta, or sin x equal to theta in this case. So this is inverse function of sin x. Here sin x is theta, or sin is taken to that side. This is inverse function of sin. Sin inverse function is known as. Whatever the value you will define, and what are the principal value, what are the general values. Similarly, if I take, let me take phi is equal to cos x. Okay, phi equal to cos x here. Therefore, x equal to cos inverse phi. In this way, here x equal to cos inverse phi, x equal to sin inverse phi. In this way, we define the inverse function of trigonometric function. Here, the trigonometric functions inversely defined. How inverse function is just calculated? Now let me take. So this is the trigonometric inverse functions. We define them in this way. Okay, sin x equal to theta, suppose, then x equal to sin inverse of this, sin inverse theta. In this case, whatever the value of x is, in this case x is in terms of angles, but x must be angle only, then sin x is defined. Sin pi by 2 is 1, sin pi by 3 is root 3 by 2, sin pi by 6 is 1.2. In this way, theta is sin inverse x, or x is in terms of pi by pi, or angles, in terms of angles. Theta is the value, numerical value, okay, like -1 to +1. So that is the principal value of, or principal interval of sin x, because most of the value, infinite value of sin x, or general value of sin x, is in between -1 to +1. X is between -pi by 2 +pi by 2. That we just talk about. But before that, if theta is to be numerical value, the value of sin x, so the x must be in terms of angles. X we substitute in terms of angles, and sin pi by 2, sin pi by 6, pi by 3, etc., pi by 4. All these values are coming in numerical terms. So theta is numerical value. Similarly, here phi is numerical value. So what is the value of x here? How x is substituted? That we define that what are those principal values. Principal value, and that this is how inverse functions are defined. So this x is, we may say 1 to 1. So x is defined, x is, this function is from x to y, from x to y, okay, and this is from y to x, from y to x. So in this case, we can say that y, if y is defined in this y tends to x, x is from, this function is from x to y, you can see this is from y to x, they are inverse of each other. Okay, so, but they must be one-to-one on the functions. Only then they are defined. So the definition we defined in case of inverse function. We initially in case of differential calculus we have defined in the beginning what are the inverse functions, how we are defined inverse functions in case of trigonometry. Sorry, in case of differential calculus. Okay, so that is also defined there. Now let me talk about what are the second point. What are the general and principal values of inverse functions? Let me take that point. This is first one question we have talked about inverse functions. How do we define them? Inverse functions are just, they must be one-to-one, then vice versa is defined. That is one function is from this to this, then the reverse of that is possible only when the function is one-to-one and on-to. One-to-one and on-to. Suppose this is x and this is y, and if I define this x to y, and then the reverse is also possible. This is from y to x. This is the inverse of this. This is direct function, or this is function. This is f inverse here. F inverse is from y to x. So just this is inverse function here. This is the 1 1 onto. Okay, 1 1 onto function 1 1. Okay, each term, or this is domain function, this is range in this case, but when we define inverse function, then this becomes as a domain and this becomes range. Vice versa of each other, domain to range, range to domain. Okay, and for inverse function, this is domain and this is the range, but for direct functions, not inverse functions, and this is domain and this is the range. That is just inverse of each other. This is how we define inverse functions. Now let me take. Okay, so this is definition of inverse functions. Now it may be trigonometric functions or any other function, x to y any function. Okay, and if it is vice versa, if it is 1 1 onto, then inverse is that distinct. Inverse function is possible only when the functions defined is 1 1 onto. Okay, let me take second question. Second question says, what are the general and principal values of inverse trigonometric functions? So let me take general value and principal values. General values and principal values. Okay, let me define them. How they are defined. General and principal values. General value means lot of values are there. If I take, we know that here we know that if sin theta equal to x or x equal to sin theta, let me take x equal to sin theta, then theta is lying between, or when theta is equal to sin inverse x. So in this case, theta is lying between, theta is greater or equal to minus pi by 2, less or equal to pi by 2. It means theta is lying between minus pi by 2 to plus pi by 2. Okay, now this is one of the values. Now, I mean, this is the range of this. I mean, theta lying between minus pi by 2 to plus pi by 2, in which this kind of intervals can be many. Many intervals are there. This is one of the intervals here. And here x is then. X can be, or x is greater or equal to minus 1 and this is less or equal to plus 1. Here value of x is. So this is, in this case, the domain of x, and this is the range here. Theta is range. For x we substitute here. The inverse of that function is calculated minus 1 plus 1. Now it can be infinite values in between these number of values are there. Because if I take that, suppose sin inverse x is there, okay, and minus 1 is this, and this theta is lying between theta, or theta is sin inverse x. If you can just sin inverse x is lying between minus pi by 2 plus pi by 2. Okay, or we can say that sin inverse x or theta is equal to n pi plus minus 1 raised power n, okay, into this theta, or here we are taking sin inverse x. Let me take this sin inverse x. If I take this as alpha, theta equal to sin inverse x, so theta is equal to this value. In this case, theta is equal to n pi. This is the general value. These kind of values, general values are there. This is general series of this. Okay, general value. And this is one of the principal values. This is the principal value for sine. Why? Because minus pi by plus pi by 2, one of the range here. Why? Because we can take minus pi by 2 to minus pi. It is minus pi is less or equal to pi theta, less or equal to pi by 2 minus pi by 2. Okay, so in this way, this is one of the good key. If I draw the graph of this, which is in next question, okay, these are the general and principal values we can define. If I take that this theta is lying, this theta is n pi, theta equal to here n pi for sin inverse x. This is n pi plus minus. In this case, x equal to this. X value is in terms of numerical values. Okay, because x is here numerical values, but this theta comes out to be, okay, theta total value comes out to be, theta can be n pi, because this is here theta we have to take, okay, in terms of n pi, pi by 2, pi by 3, etc. This is the general value, or thousands of values, number of values, the infinite values, infinite number of values are there in this case. This is general value for sine, for theta here in this case. Theta can be pi by 2, minus pi by 2, plus pi by 2, and this is one of the values. Principal value is this, because for this minus 1 to plus 1 values are here, because sine pi by 2 is 1 positive and minus pi by 2 is minus 1. So, and for sine this minus 1 to plus 1, and this is value of x here. X is lying between minus 1 to plus 1. Okay, so this is the principal value. Principal value. This is also principal branch of the values, or principal branch of the value. Branch of values. Principal branch of values. These are principal values. Okay, so in this way, in case of angles, this is minus pi by 2 plus pi by 2, and in case of numbers, for example, x must be here in terms of numbers. Theta here is in terms of angles, right, minus pi by 2 plus pi by 2. Principal value and this general values. General values be defined in this way. Theta can be lying at thousands of values, infinite number of values. If I substitute here x minus 1 plus 1 something, or sin inverse x substituted as pi and pi something like this, total value is this. Because sin inverse 1 is pi by 2, sin inverse minus 1 is minus pi by 2, sin inverse minus pi by 3 is minus root 3 by 2. So in this way, number of thousands of values can be, infinite number of values are calculated. This is the general values, branch of general value, or number of values are there, can be found out from here. This is one of the group of this, but this is principal values, because the value of sine 9 plus 1, either from all these groups we are calculating, the values are smaller, greater, but not greater than 1, is equal to 1, but not more than 1. Sine is lying between 9 and 2%. This is the principal value group. So let me take other example. And if I write, for example, in case of cos, if you take cos also, cos theta, that theta equal to cos inverse x. In this case, x can be, again, this can be minus 1 to plus 1. Here, x is minus 1 to plus 1. X is lying between, x can be minus 1 to plus 1. Okay, this is the value here. And here, theta can be 0 to, so 0 is, or here we can take pi is less or equal to 0. Okay, or this is pi. 0 is less than theta is less than pi. 0 to pi here. So at 0 it is 1, at pi it is minus 1. Minus 1 is plus 1. Less or equal to minus 1 or less than or equal to 1. So this is the group here. Minus 1 plus this minus 1 is for cos pi. Cos pi here. Theta is, if suppose pi it is, then cos inverse x is minus 1. So cos inverse x value comes out to be pi, but this is x is in that case minus 1. And if x is 1, that means 0. Okay, for this theta is 0, then cos inverse 0 is, sorry, cos this theta is 1, then cos inverse 0 is 1. X is 0 in that case. Minus 1 to plus 1 is the principal value group, and this is also principal value group. And in this case, cos inverse x, we can say, of theta is equal to 2n pi plus alpha, or this is sin inverse x, or the cos inverse x in this case. This is cos inverse x. In this case, this is suppose theta here, or theta is cos inverse x. So theta can be 2n pi plus cos inverse x. This is 2n pi plus alpha or plus something. Alpha here is this theta. So theta equal to, so number of values are here. This is general group of this. General group, we can say, or general group of values. This general group of values, and this is the principal values of principal branch of values. Principal branch of values. Here, principal branch of values. Branch of values. Now let us take, this is for cos inverse. Okay, and let me take the other trigonometric functions also. What are the other trigonometric functions, the principal values, the general values of them? Let me take them. Okay, so principal values, general values, let me take them together. If I take the general value, principal value for all the inverse functions, general and principal values I am taking here. General and principal values or branch of values. This is branch of values. Values for inverse trigonometric functions. Inverse trigonometric functions. First, let me take sine inverse. Okay, this is sine inverse here. Now for sine inverse, if I take theta or x, let me take sine here. Okay, sine. So, or if I just find out the domain and what is the range for this, that will define range and domain. So domain may be number of values. So let me take domain and range here. Domain means what? I just talked about, and this is range here. Range and domain for different values. This is for sine inverse or inverse functions. General and principal values, or domain and range here. This is or domain and range. Or domain and range for inverse trigonometric functions. For sine, that we take. This is for sine here. What is domain for this? Domain means we have to take the value of x here. What is the domain? And range is what? Okay, now in this case, domain means when we are putting the value of x, sine inverse x, suppose we are taking. What is the x here? Domain. Total value comes out to be, that's the range. Okay. Domain is here. In case x can be minus 1 to plus 1. It is a domain here for inverse functions. And range is minus pi by 2 less or equal to here less or equal to sine inverse x is less or equal to pi by 2. This is the range here. So minus pi by 2 plus pi by 2, you could write it there. Okay, or set of real numbers we can take. Domain is set of real numbers. Now in this case, set of real numbers are to take here. Let me take here set of real numbers. This is R here, set of real numbers with a range for this sine inverse functions. Now, in this case, this is for general values. If I take R here, then that is for sine only. Let me take not for inverse function. First, let me take for sine only. R is the this is for sine x for example. Okay, I am taking for simple trigonometric function, not for inverse trigonometric functions. First, let me take what are the for general and simple value. Then this reverse of that, it will be then domain for inverse function, and this is for simple functions. I'll just reverse this here. Okay. This is for range and let me write it domain and range for trigonometric functions, for trigonometric and inverse trigonometric functions, and inverse trigonometric functions, and inverse trigonometric functions. That is going to define this. Okay, so trigonometric functions, how to define circular or trigonometric functions, that I am defining here. Graphically I'll take later what are the general and principal values for inverse trigonometric functions, but before that let me take trigonometric function simply, then inverse function simultaneously. Now if I take sine inverse x or sine inverse, this is inverse function here. Sorry, sine inverse, okay, or sine inverse here. Now what is the domain for this? This is the domain here. Here I have to take minus pi by 2 is less or equal to x, sine inverse x, or let me take here minus pi by 2 plus pi by 2. In case of just this one, you have to just take that what are these values? Domain is sine inverse, sorry, in this case this is 1 only, sorry, this is minus 1 2 plus 1, because in place of x we have to put here minus 1 2 plus 1. This is the domain in this case. So the range in this case, now range can be real numbers, because this is the real numbers here. The domain is real numbers, but that tends to minus pi by 2 plus pi by 2, minus pi by 2 plus pi by 2. The value comes out to be minus 1 plus 1 if we substitute here. This is for general values. Only real numbers can be any number. This is a range here from minus pi by 2 to plus pi by 2 that we can take here. Oh, sorry, range in this case. I'm sorry, I'm writing the wrongly thing. So in this case, this is minus 1 plus 1. Same thing. Range means the value of sine x or sine theta can lie between minus 2 to plus 1. This is the range in that case. So this range becomes a domain here, and this real numbers we will be taking in this case domain in case of simple sine or trigonometric functions. But in case of inverse functions, this is just line range is minus pi by 2 plus pi by 2. But domain of this is domain is value of x here, sine inverse x. This is the range here. So this range becomes domain, and here this real number set of this is real numbers, set of real numbers. In case of sine, set of real numbers in the domain here. Real numbers can be angles as well. So that we are taking here. Now this minus pi by 2 plus pi by 2. This is the range in case of sine inverse x. Value comes out to be this minus pi by 2 plus pi by 2. Okay. Now in case of cos function. Now if I take cos function again, simple cos, this is inverse function. So for join here, I am taking cos trigonometric function. For that, this is again real number, set of real numbers, and this will be minus 1 to plus 1. The range is also minus 1 to plus 1. Okay, in case of cos inverse, let me take cos inverse again minus 1 to plus 1. And here, this is 0 to pi. 0 to pi is the range of cos inverse function. For cos inverse function, range is 0 to pi. Okay. So for cos inverse function 0 to pi is the range here. Okay. Now in case of tan function, okay, tangent of function. What is the tangent of function? Simple tan, if I take tangent or tan function, just like done here. Now I'm taking tangent here. The set of this real numbers. Now in this case, R is set of real numbers minus x, such that x is equal to R minus what? We are not to take go 1 upon 0 in infinity, not defined. This value will be twice n plus 1 into pi by 2. Because for that, and this tangent is not defined. Tan 90 degree is how much? Tan 90 to 270 degree is multiple of pi by 2. For pi by 2 or multiple of pi by 2, tangent is not defined. But that is infinity. Sin 0, sin 90 upon cos 90, cos 90 0 to 1 upon 0 is not defined. So this is we have to remove here. Here where n belongs to, or n here belongs to, or n is equal to, n belongs to, let me take z here. Z or g is a set of integers. Here n can be integers, negative or positive. Okay, so this is what we have taken for simple tangent function. Okay, so this is your domain here. And range is okay, its range comes out to be minus infinity to plus infinity. Okay, and range comes out to be for second case set of real numbers. Now in case of tangent, set of real numbers, because infinity to plus infinity. This is your range. Range is real numbers, set of real numbers. Any number, infinite numbers are there. We can take, this is for simple tangent here. But let us check what is tan inverse then. For tan inverse or inverse of tangent, what is the domain here? Domain is real numbers. You can just take it here. So this is set of real numbers R, and this taken to be a range here. What is the range for this? And this is, we can say, principal values, or this is here the general values. General value we are defining that for real numbers, number of real numbers are there. But in case of range here for tan inverse, this can be again R minus x here, such that x equal to twice n plus 1 into pi by 2.